Okay, hello. I want to show you the progress on what we call the Fluent add-on for Cerebral. It basically makes Cerebral type safe, meaning that you can use it with Typescript, and you get all kinds of help when writing your code. Now, one thing that has been really important is that we wanted to be like one really good way to use Typescript, and it should infer as much as possible. Basically, what that means is that you shouldn't have to write that much TypeScript-specific code. It should just magically work. So I want to show you where we are right now. And this is the to-do MVC using the Fluent add-on. And you will basically import most stuff from the Fluent add-on, like the controller, the model, and even when you connect to React, you import that from Fluent. But like the dev tools, you still import from Cerebral. And as you can see, this is the index file, nothing special about this. We render it out and everything's good. What to take notice of is this new file. I'm calling it globals now. Like the specific API and the conventions related to this are not settled yet. But I can explain at least the concept. So in globals, this is where you describe your application, like what providers do you have, and you also describe like the context. This is related to running signals. So what is on the context? This is where you put the state of the application, and maybe other stuff. Like you have, and in this case, we are like extending providers. So also providers are part of this context. And then we have context with paths. And this is, you will see later, that you need, you have to define a different context for actions that output paths. So just stick with me on this, and I'll show an example. And then we have a connect. So you're not using connect directly from Cerebral Fluent. You define your own connect factory. And this is because you want to tell it what is the state and what are the signals. So this file is something you have to create, but you usually just have to create it once, and then you change the typings inside the different modules, and this will just work. Yes. So let's move on to a module to see what changes are to the Cerebral code. So as we can see here, we're exporting a module, and we're giving it the expected state and signals for this module. So that means if I change something here, it starts yelling at you if you're giving it the wrong types. As we can also see here, we have something called an observable map, and this is related to Mobx running underneath. So you have to define, like if you just had an object with some properties, you don't have to define a map. A map is when you have an object where you're going to add and remove properties. And it's really nice to call it a map, because that is what we usually use it for. Like you have some users, for example. So you have a map of users where the key is the ID of the user. And then we have computed. And computed is where you have a value that is created by combining other state. I'll show you how it's defined. And then we have the signals, which looks exactly the same. So let's check out these types here. So I created a file called types, and I have created a to-do type, and also the state with a description of the types here, like a string, an observable map of to-dos, blah, blah, blah. We have computed value, which we use wherever we want to compute something. And we describe what the returned result is. So for counts, it's an object with this structure. And for visible to-dos UIDs, it's just an array of strings. And is all checked, it's Boolean. And then we have the signals, where we actually define what we expect the signals to receive as a payload. So we have two different types for this. We have just a normal signal type, which means there is no payload. And then we have signal with payload. And you describe what do you expect the payload to be to this signal. Cool. And that is what is used to figure out what is the correct definition of your module. So let's have a look at sequences first, or maybe we should look at the computed. So I call it getters, and computeds are just a function where the context of the function, like the this of the function, is the state of the module. So here we are just using normal code where any computed uses the get method to grab the value. So it says visible to do's UIDs as a get method, so you use that to grab the data, because visible to do's UIDs is also a computed. And then you have a to do, and it shows you how it's structured, and blah, blah, blah. You see everything, which is the cool thing about TypeScript. You can just hover whatever value, and it will tell you what it is, or what's available. But basically, that's it for computeds. It's just a function where the this points to the state of the module. Cool. And then we go to sequences, and this has changed a little bit. It's a chained API instead, so there's more fluff here, but it's actually needed to infer different stuff. So let me show you here. We have redirect to all. It's a sequence where we pass in the context we have defined for our application. And we also define what properties does this sequence expect to be available. And this is really important because you can compose one sequence into another sequence, which means that when you define, okay, this sequence requires these props, and if you try to put redirect to all into other sequences, it will yell at you if that sequence, like the sequence you're composing into, is not providing this required prop. So you're actually unable to put a sequence into another sequence where the props aren't matching, which is really important. And then we are pointing to an action. But what I want to show you here is that if I chain further here, you see that we can add an action, we can add parallel, we can add a path section, or a sequence. But let's add something here, and let's go and look at the state. So inside this action, I can do state dot, and it tells me what's available, like this. And if I do, oops, sorry, I do props, it will tell me that filter is available, because that's what it says up here. So when you have an inline action like this, it can infer what's the state and the props by looking at the context up here and the string up here. And the safety is now in the signal definition. So the signal definition of this redirect to all is root routed. And root routed expects the payload to be a filter, which is a string. And this is exactly what this sequence also requires. So if that was not the case, you were actually trying to use redirect all on a signal that did not match up with the properties, it would yell at you. Okay, I hope this makes sense. Maybe you have to use TypeScript to understand this, but it's actually pretty cool. It just gives you all this safety in the composition. And this was something that was not clear to me initially, is that Cerebral is all about composition. You can use actions multiple places, sequences multiple places, and when you make changes to this, you never know if they actually match up without running it, or kind of like putting a lot of stuff into your head. But with this TypeScript approach, you will instantly know if an action works in a sequence, or a sequence works inside another sequence, or a sequence works as a signal. By just trying it, it will tell you if it doesn't work. Okay, cool. Now, yeah, so let's move on here. It's the same concept. Here we can see a sequence where we have a paths action, and it basically means that this action needs to output a true and a false path. And we can see that this is okay because it actually checks that this action does indeed output true and false. So it's pretty awesome. And then we can see, yeah, I guess that's okay. Cool. So let's move into actions. Now, actions are defined the same way. The only thing that's different is that you give it the context, like what's available inside this function. And you can optionally give it some required props. And this is not to like, okay, by putting this in here, it will say that props.title is available. But what it helps with is not really about making it available when you type it here. It's to ensure that when you use this action inside the sequence knows what props are available. So it will actually yell at you if this action requires a specific prop and it doesn't match up inside the sequence. So that's the important thing about putting it up here. Okay, so we see here we have like a normal action, and because we attach the context, we have access to the state. It will tell you everything. And now we see Mobx in action here, because we can just point to the state and do normal mutations. We don't have to use the traditional API of Cerebral. And this is really important for type safety. It needs to work like this, or it's impossible with like a string API to infer the values and everything. Okay, and then we should have down here, we have context with paths. It doesn't expect any props, but it expects, or it outputs a true and a false path. Currently, I have to use this object here. So this has to be fixed, so it doesn't necessarily have to. So like now it says it's wrong, but you should be able to do this. Anyways, the point is that you say that this is an action with paths, and you output as normal. Cool. Yes, and then let's move on to the components. Let's look at app. So the way you connect your components is to use this connect that we defined for this application. And this connect knows about all the state and signals available in your application. So when you connect with, you get the state, the signals, and any props that would be passed from a parent component. And the way you define what props are required would be up here. So if the parent component, it was required to pass in foo string, you would define that here. And from the outside, using this component, it would yell at you if you didn't pass in this foo string. Cool. So here I could do state. You got everything available here. You got all the signals. And this is where you define your dependencies. And then you connect it to, in this case, a function, stateless component, and it's inferred all the way. So since you had counts here, you get counts here, and you have all the information you need to figure out what is available on counts, for example. Now, one thing, yeah, and you can also use a class. You can say toClass. This actually receives the props, and you return the class. And the reason you do this is because when you create classes in general, you have to provide like the generic stuff, or whatever it's called. So let's say app extends react.component, and you would say type of props. That is what is passed into this component. Okay, so you have two, which is for stateless components, which you usually use, and then you have toClass, so that you're able to give it the type of props. Oops, type of props, like that. And then we should have this.props. Yeah, you see we have counts here. Okay? And this is the important part. We have to figure out an API that doesn't bloat. You don't have to create all these typings. That's the really shitty part about TypeScript if you don't do this API right. So we are working really hard on making it very easy to use this. Yes, one thing about Mobx and having a separate dependency callback is that, for example, on a to-do, like here, we are using, for example, to-do completed. But if we were to only depend on the to-do itself, it would not re-render when, for example, completed changed. We have to be perfectly explicit about what properties are we using inside this component. So what I'm basically doing here, I'm grabbing the to-do, and then I'm passing in what properties am I actually using on this in this component. And that ensures that it does indeed re-render every time. What's nice about this is that you are extremely explicit about what it needs down here, but also this connect becomes generic. So it means that we can use it for Vue and Angular and whatever else. But okay. Yeah, I also want to show you, as you can see here, toggle completed changed. You see what the payload should be to the signal, which is nice. So you can't really go wrong here. And the extremely important part here is if you have a complex application and you change something, it will just instantly tell you what components were affected by this, what sequences, what actions, what modules. Like it knows everything, and it can tell you about everything when you're coding, and it will yell at you if you change something and it breaks. So that's really nice. Okay, so for the grand finale, we are going to look at the actual application. I'll add a to-do here, and it's working. And if we look at the Cerebral debugger, it actually shows the state changes. So this debugger is running the normal Cerebral, but because we are able to, by using something called proxies, and this is only for development, the proxies, they're nothing to do with production, is that they're actually able to figure out how you do your state changes and convert that into something that the debugger understands. So it can actually, even though we're not using Mobx in the debugger, we can reproduce the state exactly the same way because of this proxy translation thing, which is, it's really awesome. So that means you get the full debugger experience with full type safety in Cerebral. And I'm super proud of this, that we're actually able to do this. So I hope you like it. And we still have some work to do. There are some bugs related to this proxy thing that needs to be fixed, and also nailing like the API and the convention of files and stuff, so that we at least have a recommendation on how to use it. But yeah, I think this will be a big deal for Cerebral, because that's always the question, like, what about TypeScript? And now we have used the Fluent add-on. Sweet. Thanks for watching. Hope you like it. Talk to you later.